Good morning, everyone. In this online class, I will discuss polarization. So, before starting polarization, we should be aware of what is the meaning of polarized light, what is the meaning of unpolarized light. Apart from this, we should be aware of many other terms like plane of vibration, plane of polarization, S-polarized light, P-polarized light. So first I will discuss all these terms which are required to discuss polarization. First I will start with plane polarized light. So first question arises, what is the meaning of plane polarized light? So if we are considering light, then light is an EM wave. Light is an EM wave. It consists of three vectors, E vector, B vector and K vector. And all these three vectors are mutually perpendicular to each other. So all these three vectors, E vector, B vector and K vector, they are all mutually perpendicular to each other. And out of these vectors, this E vector is responsible for different polarizing state of the light. So basically polarization is dependent on this vector, that is electric vector. So to understand what is the meaning of plane polarized light, I am drawing a wave, a transverse wave or a light wave. Here suppose this direction is Z cap and this is X cap direction, and a wave of electric vector or oscillating electric vector are plotted like this. So this is the direction of oscillation of electric field. So electric fields are oscillating in XZ plane. So from this diagram I can observe that this electric field, this is electric field vector with this is oscillating in XZ plane. So basically here this electric vector is confined in this XZ plane. So this is a type of plane polarized light. So plane polarized light means all the electric vectors of this type of EM wave are confined in a particular plane. So this is an example of plane polarized light. Here electric vector is in X cap direction, this is propagating in Z direction. So this electric field can be written as E cap. Vibrations are in X cap direction, so I will write here X cap. Amplitude of this is suppose A and sine omega t minus kz. So basically this is the electric field profile of plane polarized light. Here you can observe that these electric vibrations, they are all confined in this XZ plane. Similarly, these electric vectors, they can be in the Y cap direction. Suppose wave is propagating in Z cap direction, this is Y cap direction. So again we can have a wave like this, and electric vectors, they are now oscillating in the YZ plane. So here electric vector is oscillating in YZ plane. So in both these cases you can observe that electric vector is confined in a plane. Here this is confined in XZ plane, here they are confined in YZ plane. Here electric field profile can be written as, this will be Y cap, because electric vector is oscillating either in upward direction or in downward direction, but they are in Y cap direction. Amplitude A and sine omega t minus kz. This Z is basically representing that this wave is traveling in the Z direction. So this is this Z cap is the direction of K vector and electric vector is in Y cap direction. So these two are the examples of plane polarized light. So now we can define plane polarized light. Basically plane polarized light is an electromagnetic wave in which all the electric vectors are confined in a particular plane. So these electric vectors, they are restricted to oscillate in a particular plane. Now question arises, how we will denote these plane polarized light. So basically first we will draw a line which will represent the k vector. This is k vector, and electric vectors are perpendicular to this, so they will be shown by these arrows. So here they are confined, these electric vectors, they are confined in the plane of this board. So this is the representation of plane polarized light. So I hope now you can understand that plane polarized light is that light in which electric vectors are confined in a plane, and this plane consists of this k vector. If suppose these EM wave, they are propagating either into the board or outward of this board, then we can represent plane polarized light like this. So we can also represent plane polarized light by this. So this is the direction of electric field, and wave is propagating like this. So either in this direction wave is propagating or it is moving out. Now question arises, if this is plane polarized light, then what is the meaning of unpolarized light? What is the meaning of unpolarized light? So here in this case of plane polarized light, we have electric vectors in a particular direction. Now suppose there are large number of waves and whose electric vectors are in all random directions, and all these infinite number of waves or large number of waves, suppose they are propagating in this direction inward the board. So basically, if in place of one electric vector direction we have large number of waves whose electric vectors are in quite different directions, but they are propagating in the same direction, means their direction of propagation or their k vector is same, but they are superimposed in such a way that their electric vectors are in different direction. So here then their superposition of these large number of waves will form unpolarized light. So we can say unpolarized light is a superposition of large number of plane polarized light whose electric vectors are in random direction. However, all these electric vectors, they are perpendicular to k vector, but there are electric vectors in all possible directions. So in plane polarized light, basically we have a light in which electric vector is confined in a plane, and in unpolarized light electric vectors are oriented at all possible directions. If we consider this at the starting axis, then at every angle 1 degree, 2 degree, 3 degree, 10 degree, 50 degree, at every angle you will find out an electric orientation. So basically unpolarized light is a superposition of large number of plane polarized light which are propagating in the same direction. Example of unpolarized light is tube light or light emitted by the bulb. So light emitted from the tube lights and the bulbs are the examples of unpolarized light. Next is two type of planes we can define. One is plane of vibration and another is plane of polarization. So here we have two examples of plane polarized light. Here this is the first example, this is the second one. In first example you can observe that this plane polarized light is confined in xz plane. So basically all the vibrations of this plane polarized light lies in xz plane. So this plane which consists of all the electric vibrations. So the plane which consists of all the electric vibrations, and this plane also consists of k vector, then this plane is known as plane of vibration. So plane of vibration is the plane which consists of all the electric vectors. Here basically this is the z direction, this is x cap direction. So these electric vectors are basically oscillating parallel to this board. So this board is plane of vibration. So here in this case, basically xz plane is acting as plane of vibration. It consists of all electric vectors as well as this k vector. Another plane is plane of polarization. So plane of polarization is that plane which is perpendicular to plane of vibration. So first condition is it is perpendicular to plane of vibration, and second, it doesn't consist of any electric vibration. So basically a plane which is like this, which is perpendicular to this board, basically YZ plane. Here this YZ plane, this will not consist any electric vector, and this is perpendicular to the plane of vibration. This YZ is known as plane of polarization. But there is one common thing in plane of vibration and this plane of polarization, that is intersection line. So basically these two planes which are perpendicular to each other, they intersect each other, and they intersect along the k vector. Basically the line representing their intersection is the k vector. So basically plane of polarization is the plane which doesn't consist any electric vector. This is perpendicular to plane of vibration, and this also carries this k vector. So they are perpendicular to each other, and they are intersecting along the k vector. So basically these are two planes which we will use many times in this polarization. Next is the type of plane polarized light. Here you should consider that there are different type of polarized wave, like plane polarized light, circularly polarized light, elliptically polarized light. But here I am focusing only on plane polarized light. Right now I am not discussing circularly polarized or elliptically polarized. We will discuss them later. So basically this plane polarized light, now question is plane polarized light. This plane polarized light can be classified into two type of plane polarized light. One is known as P-polarized and another is known as S-polarized light. So how this classification is done? This classification is done on the basis of a plane that is known as plane of incidence. You are aware about plane of incidence from class 12. So, but basically I will give you a small idea about this. Suppose this is x cap direction, this is a plane, this is xy plane. Here this is first medium, this is second medium, and suppose a wave is incident on this. This is the ki vector, and this is incident wave. A part of it, this is the normal to the interface, then a part of wave will be reflected back. So this is the direction kr, this is the reflected wave, and this is kr vector. A part of this will be transmitted into the second medium, and this represents the kt, this is the transmitted. So for an incident wave, we have a reflected wave, we have a transmitted wave, and this ki, kr and kt are their respective k vectors. So a plane which consists of ki, kr vectors and kt vector, along with normal to the interface. Suppose this is the normal, so and this normal. So plane that consists of ki vector, kr vector, kt vector, and this eta vector. Eta is the normal to the interface. That plane is known as plane of incidence. And basically on the basis of this plane of incidence, we can classify PPL into two types. One is known as P-polarized, another is known as S-polarized. So here you can observe that this plane of incidence is basically the surface of this board is acting as a plane of incidence. So now we will define what's the meaning of P-polarized, what is the meaning of S-polarized light. So to understand P-polarized light, we have an interface. Again, this interface is represented by X, Y, and a wave is incident from this side. A part of it is reflected back, a part of it is transmitted into second medium. So basically, if this is plane polarized light, then its electric vector can have two orientation. One can be parallel to plane of incidence. If its electric vector of this plane polarized light is parallel, if electric vector of this plane polarized light is parallel to plane of incidence, then this plane polarized light will be known as P-polarized light. This is known as P-polarized light. So if electric vectors are parallel to the plane of incidence, then this is known as P-polarized light. There can be another case. If this is an interface, XY interface, a wave is incident, a plane polarized light wave is incident on this. Again, a part of it will be reflected back, a part of it will be transmitted into the second medium. And if the electric vector of this incident plane polarized light they are perpendicular to the plane of incident, then this plane polarized light is known as S-polarized light. So basically these are two particular orientations of electric vectors. If electric vectors are parallel to plane of incidence, then this plane polarized light is known as P-polarized light. If electric vectors are perpendicular to the plane of incidence, then this plane polarized light is known as S-polarized light. Now question arises, how can we produce this PPL? How can we produce this plane polarized light? How this can be produced? So basically there are various techniques or various methods with the help of which we can create this plane polarized light, like a scattering method. By taking a stack of parallel glass plate, we can create or we can produce plane polarized light. But here I am going to discuss two very simple methods. One is known as by reflection, production of plane polarized light. So this is production of PPL by reflection. Basically, this is based on the concept, this PPL is based on the concept of Brewster angle or angle of polarization. If we have this interface, if this is the first medium, this is the second medium, and this is the interface between them, and if S-polarized light is incident on this, means electric vectors are perpendicular to plane of incidence, then you will find out that there will be a reflected wave. If this S-polarized light is incident at Brewster angle or angle of polarization, then you will find out there will be a reflected wave and a part of it will be transmitted and there will be a transmitted wave. Both these waves will also be S-polarized. Similarly, this is the case for S-polarized. Now, in second case, if the incident light is P-polarized, this is P-polarized light, then you will find out, then P-polarized means electric vectors, they are parallel to plane of incidence. Then a part of it will be reflected back and a part of it will be transmitted. And again, if angle of incidence is theta p, then for this case you will find out that amplitude reflection coefficient becomes 0. Amplitude reflection coefficient is 0. It means in this case there will be no reflected light. There will be no reflected light at Brewster angle. So what you are observing, that if S polarized light is incident, then a part of it will be reflected back. But if the incident light is P polarized at this Brewster angle or angle of polarization, then there will be no reflected light. So on the basis of this concept, one can easily create plane polarized light. If this is the interface, and unpolarized light is incident, means this unpolarized light, this consists of both electric vectors parallel and perpendicular to plane of incident. This is unpolarized light. Then, and suppose angle of incidence is Brewster angle, then what will happen? This dot line, they will be this S polarized, components of this S polarized, they will be reflected back. And in the transmitted light, both dot and parallel lines both will be present. So here in this case, this will be plane polarized light and this will be S polarized. And in the transmitted light, this is partially polarized light. So if unpolarized light is incident on an interface at Brewster angle, then in the reflected part we will get plane polarized light, and this plane polarized light will be S polarized. For this, formula for this Brewster angle is tan theta p is n2 upon n1. This is n2 upon n1. I can also write this as sin theta p upon cos theta p equal to n2 upon n1. Now if we use basically, if this angle is basically angle of refraction r, this is angle of incidence theta p, then by using Snell's law you will find out here we will have sin theta p, and this will be divided by sin r. So basically sin theta p will be cancelled out and this cos theta p will be equal to sin r. Cos theta p, it can be written as cos pi by 2 minus theta p equal to sin r. So here I can replace by sin. I can write this cos theta p in terms of sin. So from this, by comparing the argument of these two sign terms, we can observe that theta p plus r equal to pi by 2. So what is the meaning of this? This angle is r. This angle is theta p. So if I consider this line, so basically this angle plus this angle, they are 90 degrees. So automatically this angle will also be 90 degrees. So it means after reflection, reflected light, after basically when unpolarized light is incident on an interface, then reflected light and transmitted light, they will move perpendicular to each other if angle of incidence is theta p. So by using this reflection method, we can produce plane polarized light. So this is the first method. Second method is basically by using the polarizers. So production of plane polarized light by using a polarizer. This article is also known as Malus law. So here by polarizer. So what is polarizer? Polarizer is an optical device. This is a glass plate like device, optical device, in which a line is drawn, and along this line, suppose this line is here and this line is known as pass axis. This is polarizer, suppose. and this is path axis, then when the light is incident on this, then all the electric vectors which are parallel to this path axis, they will pass through this, and any electric vector which is perpendicular to this, they will be either absorbed by this polarizer or they will be reflected back. So what I am saying, if this is the perpendicular line and this is the path axis, then any electric vector that is parallel to this, that will pass, and electric vector which is perpendicular to this, that will basically reflected back or that will be absorbed by this. So if unpolarized light will incident on this, then only electric components which are parallel to this path axis, they will pass, and all the electric components which are parallel to this perpendicular line, they will be reflected back or absorbed. So whatever light on the second side we will find, that will be plane polarized light. So here if a light is incident on this, and suppose amplitude of this is A, so a light is propagating like this is polarizer, this amplitude, this electric vector amplitude is making an angle theta degree with the path axis, then component of this A along the path axis is A cos theta, perpendicular to this will be A sin theta. So basically this A sin theta, it will be reflected back or it will be absorbed by this polarizer, while this A cos theta, that will pass through this path axis. So intensity on the other side, that will be equal to A cos theta square. This is amplitude square, so this will be A square cos square theta. This A square is the intensity, basically this is the intensity of the incident light, so I can write this as I equal to I naught cos square theta. So this is the formula of intensity on the other side, and this is known as Malus law. But you should always remember that this Malus law is applicable only plane polarized light. If plane polarized light is incident on a polarizer, then on the other side, basically intensity will be I equal to I naught cos square theta, where theta is the angle between the incident electric vector and the path axis of the polarizer. But if incident light is unpolarized light, then a large number of electric vectors will incident on this. Basically, in that case, this theta will have all possible values. There will be large number of electric vectors, and these electric vectors have random orientation with respect to this path axis. So on the other side, we will have intensity that will be equal to the average intensity, and this average intensity will be I naught cos square theta. If you find out the average value of cos square theta, then this average value will be 1 by 2. So this I will be equal to I naught by 2. So from this we can conclude that if the incident light is unpolarized light, then on the other side we will have intensity I equal to I naught by 2, and if the incident light is plane polarized light, then on the other side we have intensity I equal to I naught cos square theta. So basically on the basis of these two methods, one by reflection and another with the help of polarization, we can produce plane polarized light. So these are the introduction of polarization. We should well aware about these terms, these expressions to understand the polarization.